Today we're going to be talking about exponential functions and the natural exponential function called y equals e to the x. Would you prefer that the light is off at the screen, or is it okay as it is? Okay, so our goal here is to learn about exponential functions, their graphs, learn about the natural exponential function, and some they're not natural properties that come along with it, some other concepts that are applications of exponential functions. For example, compound interest and continuous compounding. So let's start out with a definition. If a is greater than 0 and a is not equal to 1, then f of x equals a to the x defines the exponential function with base a. Okay? Note that up. If a is equal to 1, so if you put a equals 1 here, you're just going to have 1 to the x, which just means that this function is going to be the constant function defined by f of x equals 1, which is not an exponential function. So that's why we say a is not equal to 1, and we also say a is greater than 0. Okay? The domain of f of x equals a to the x is the set of all real numbers. So now let's talk about the graph of a to the x. Let's talk about the graph of a to the x. So, f of x equals a to the x, where a is greater than 1, has the following graph. It looks like this. Okay? This y-intercept is the point 0, 1. Another point on the graph is 1. And then you have 1a. So notice that if you substitute in x equals 0, you have a to the 0, which is 1. If you substitute x equals 1, you'll have a to the 1. That's why you get a. Then if you substitute in x is equal to negative 1, what do you get for y? Not negative 1a, you would have a raised to the negative 1. But what's that? 1 over a. Good. So you would have the point negative 1, 1 over a. Good. Notice that this function is increasing. So these are some properties of the graph of the exponential function when a is greater than 1. It's increasing. The domain is negative infinity to infinity, or all real numbers. The range, what are your possible y values? What are your possible y values? Good. So your range here would be 0 to infinity, not including 0. Very good. And remember, you read that from the y-axis. Notice that this graph is going to get close to 0 but never be equal to it. So you can also say that you have an asymptote, a horizontal asymptote. You can say that your asymptote, or your horizontal asymptote, will be the x-axis, or y equals 0. Now, when a is between 0 and 1, the exponential function looks differently. It looks like this. So you will still have your y-intercept as 0, 1. So then, if you have x is negative 1, what is your y? 1 over 1a. What did you say?
Negative 1a.
No, it's not negative 1a. f of negative 1 is equal to a to the negative 1. 1 over a, good. It's 1 over a. So you would have negative 1, 1 over a. Then if you have the point 1, if x is 1, what's y? A, good. Is this graph increasing or decreasing? Decreasing, good. What is the domain? Good, negative infinity to infinity. What's the range? 0 to infinity, good. And what's your asymptote? Your horizontal asymptote? The x-axis, good. Good. So notice that the reason the graph is decreasing when a is between 0 and 1, take a to be 1/2. If you have a is equal to 1/2, then what would this be? It would be 2. Very good. It would be 2, right? Because you're doing 1 divided by 1/2. So you would get 2. And notice that here you would have 1 1/2. So notice that it would be small. It would be decreasing. Okay? All right. Great. So remember we talked about 1-to-1 a while back? Do you remember that? Yeah. Okay, so we're going to revisit some of those properties, but we're going to review them or view them in terms of properties of exponents because we're talking about exponential functions. So for any real number a greater than 0, a not equal to 1, the following statements are true. A to the x is a unique real number for all real numbers x. A to the b equals a to the c if and only if b equals c. So this is where you're using the property of 1-to-1 here. If a is greater than 1 and m is less than n, then a to the m is less than a to the n. If a is between 0 and 1 and m is less than n, then a to the m is greater than a to the n. So make sure you understand that, notice it reversed the sign whenever a is between 0 and 1. Okay? Now, let's look at some actual examples and let's find each of the following. If f of x is equal to 2 to the x, let's find each of the following. Let's find f of negative 1. F of negative 1 would be equal to what? 2 to the negative 1, good, which you can rewrite as what? 1/2, good. So that's part A. F of 3 would be equal to what? 2 to the third, good. That gives you what? 8, good. F raised to the 5/2, F not raised to the 5/2, F of 5/2 equals what? Good, 2 to the 5/2, and how would you think about it moving forward? Do you need help with that? Yes?
Decimal would be 5.65.
No, not decimal. Use properties of exponents.
Could you repeat that?
You're using properties of exponents. We're not just going to enter it into the calculator. So here, you could rewrite this as 2 to the 5th raised to the 1/2. 2 to the 5th is what? No, that's 2 times 5. 32, good. So 32 raised to the 1/2. But that's the same thing as the square root of 32. What perfect square lives inside of 32? So you would write this as the square root of 16 times 2. And that's the same thing as the square root of 16 times the square root of 2, which is 4 square root of 2. And that's your final answer there. Okay? So the idea is whenever you're simplifying your radicand and you're trying to take the square root of it, you choose the one that's the largest possible for you to take a perfect square. Okay? Now, some things to point out from the graph that we talked about that you may have already made the observation, but just to point out. Characteristics of the graph of f of x equals a to the x. These are 3 points that are always on your graph. -1, 1 over a, 0, 1, and 1a. They're always on the graph of a to the x. It doesn't matter if a is between 0 and 1 or a is greater than 1. Now, if a is greater than 1, then f is an increasing function. If a is between 0 and 1, then f is a decreasing function. The x-axis is a horizontal asymptote. The domain is -infinity to infinity, all real numbers, and the range is 0 to infinity. Okay? So those are characteristics just pointed out as an observation. We've already done that by looking at the graph. What questions do you have? Okay. So now we're going to use the properties of exponents to simplify each of the following. What will we do with part 1? You have 3 raised to the square root 2 raised to the square root 2. What's that? Very good. It's 3 raised to the square root of 4. Good. And 3 squared is? 9. Good. Very good. And then in part 2, we have 3 raised to the square root 2 squared. Do you know what 3 to the square root 2 is without entering it into a calculator? That's a question. I need you to respond. Talk. Y'all are giving me blank looks and stuff. I don't know how to understand that.
No.
Okay. So, what you can do is exchange the square root, or flip, or exchange the 2, or switch the 2 and the square root 2. Because the exponent will still technically be the same. So we can rewrite this as 3 squared raised to the square root 2. And what is 3 squared?
9.
Good. So we get 9 raised to the square root 2. And that's all we can do with this one. What questions do you have? Yes?
How would you leave it at 9?
So, example 3, we can also go through and solve exponential function equations. So, that will go back to using the following property. So just recall. So I'm going to do a recall. There was a property that said a to the b equals a to the c if and only if what?
B and C are equal.
Very good. If and only if b equals c. So this is using the one-to-one property for exponential functions. So, in this example, I gave you 4 to the x equals 8. How can we rewrite these functions? What will be the base that we rewrite them in terms of? We can rewrite this. We can rewrite 4 as 2 squared, but that's raised to the x. And then 8 you can write as what? 2 to the third. Good. So you have 2 raised to the 2x equals 2 to the third. Now what can you say?
So the exponents equal to each other.
That's right. Your exponents are equal to each other because the bases are the same. So 2x equals 3, or in other words, x equals what? 3 over 2, or 3 halves. Very good. Very good. And there's a way you can check it. So this is just an aside, but if you want to check, then you can say, you can go back and substitute in 3 halves for x to see if when you simplify it, you get 8. So you have 4 raised to the 3 halves. That's the same thing as the square root of 4 cubed. Are you okay with that jump in steps? Or do you need to see a step in between?
It's seven.
Okay. So this is the same thing as 4 cubed raised to the 1/2, which is the same thing as the square root of 4 cubed. And the square root of 4 cubed is the same thing as the square root of 4 squared times 4. But the square root of 4 squared is what? So you can rewrite that as the square root of 4 squared times the square root of 4. The square root of 4 squared is what? 4, good. And then the square root of 4 is 2. So 4 times 2 is 8. So you did get 8. So it checks. X is equal to 3/2. Okay, now let's graph each of the following functions and specify the domain, the range, the intercepts, and the asymptote in each case. Would you like me to go through the first one with you? Okay, so we remember with the graphs of these functions, what are 3 points on the graphs of exponential functions? Talk a little bit louder. Yes. Yes. And 1a. Good. So those are 3 points that are always on the graph. Okay. So let's start out with the basic graph of 2 to the x. Okay, the basic graph of 2 to the x, it looks like this. 2 to the x looks like this. That's your basic graph. Now, in part 1, I gave you y equals negative 2 to the x. So what this negative 1 does on the outside, it tells you to take this graph, flip it about the x-axis. When you flip it about the x-axis, that graph becomes this. It's the mirror image across the x-axis. Does that make sense?
Yes.
Okay, so what we have here, this point here would be 0, -1. Remember we said that 3 points that are always on the graph? So if we go back to 2 to the x, 0, 1 would be on the graph. When x is 1, we'd have this point would be 1, 2.
Does the red arrow represent the negative 2x?
The negative 2 raised to the x.
So not 2 raised to the x.
I'm sorry, what?
So not 2 raised to the x, that's for the black line.
The black line is f of x equals 2 to the x.
Okay.
The red is part 1.
Okay.
So, then you have, if you have, that's what you have if you have 1. You have, your point would be 1, 2. If you have -1, your point would be -1, 1/2. And now, to finish or to plot your 3 points on this graph, which is y equals -2 to the x, you have 0, -1. Whenever you have 1, what is this point? What is that point?
-2.
So you have 1, -2. Good. And then whenever you have -1, what is this point?
-1/2.
That's your y. So your point, good. Your point would be -1, -1/2. Good. So notice that the only thing that happened, your y values became negative. Okay? That's reflecting your graph across the x-axis. Now, notice that for part 2, you have y is equal to 2 raised to the negative x. That's the same thing as 2 raised to the -1 raised to the x. What's 2 raised to the -1?
1/2.
1/2. Good. So this is the same thing as 1/2 raised to the x. What do you expect to happen to the graph? Increasing or decreasing?
Increasing.
Decreasing. Why?
Because it's,
Make sure you're only doing things related to this class while you're here and not doing other things on your laptop. But go ahead.
It's like in between 1 and 0.
In between 0 and 1,
Yeah.
yes. It's in between 0 and 1. Now, is it going to be reflected across the x-axis, or what is it going to happen? What's going to happen? What is it going to look like? That's what I'm asking. You told me it's decreasing. I agree with you. It's decreasing.
Shouldn't be active though. I'm not sure.
It's not going to be reflected, but what is it going to look like? You're right. It's not going to be over here. It's not going to be in quadrants 3 and 4. It's going to be in what 2 quadrants?
1 and 2.
1 and 2. Good. And you told me it's decreasing.
Yeah.
So it's going to look like this. It's going to look like that. So notice that you have this point. You still have 0, 1. What is another point? What do you have when x is -1? Y is? 2. Good. What do you have for y when x is 1?
1/2.
1/2. Good. So that's what we have so far. So let's go ahead and point out some information, right? Because for each of these, we should be specifying the domain, the range, the intercepts, and the asymptote. Okay, so let's go ahead and set this up. So we're going to identify the asymptote, and when I say asymptote, I'm talking about the horizontal asymptote here. We're going to also talk about the x-intercept, the y-intercept, the domain, and the range. We'll talk about that for each part. Okay, so for -2, let me erase that. So -2 raised to the x. What's the asymptote? The what axis?
or x-axis.
The x-axis, good. Or y equals 0. Is there an x-intercept?
No.
No.
None, so there's none. What's the y-intercept?
1.
Y's intercept is what?
1.
-1. This is this graph. So -1 or 0, -1. What's your domain?
All of them.
So in interval notation, -infinity to infinity. What's your range?
0 to -infinity to 0.
-infinity to 0. Because notice you're reading it off of the y-axis. It doesn't go past 0. It gets close to it, never equal to it. Okay? So, good. Let's identify that for 2 raised to the -x. So 2 raised to the -x. What's your asymptote?
X-axis.
The x-axis. X-intercept? None. Y-intercept? 1 or 0, 1. Domain? Provided an interval notation, and instead of just saying 1 for the intercept, provide the point. Range?
0 to
Good. Okay, so take a minute, graph part 3, and identify all of the information. Tell me Which graph is being affected in part 3? Which one are you using, 1 or 2?
2.
2, good, you're using part 2, and what does this minus 2 mean?
It's gonna be shifted to the right by 2.
No. Down by 2, very good. It shifted down by 2. If it were negative x minus 2, if the minus 2 were in the exponent, then yes. But because this minus 2 is on the outside, it says take this green graph, shift it down 2. So this is at 1, that's 0, and then we go to negative 1 there. So your graph looks like so. Okay, so what is your y-intercept? 0, negative 1. Good. And remember, to find your y-intercept, you can set x equal to 0, so that would give you y equals 2 to the negative 0 minus 2. 2 to the negative 0 is the same thing as 2 to the 0. So you get 1 minus 2, which is negative 1. Okay, so good. All right, what is your x-intercept?
Negative 1, 0.
Negative 1, 0. Very good. Negative 1, 0. Okay. Now, we could have made it look a little bit, could have made it more accurate. Okay. There you go. And then, what's your asymptote?
Y equals negative 2.
Y equals negative 2. Good. So this is 2 raised to the negative x minus 2. And then what's your domain?
Negative infinity to infinity.
Good. Negative infinity to infinity. So the dashed line is your horizontal asymptote. And what's your range?
Negative 2 to infinity.
Very good. Negative 2 to infinity. What questions do you have? Good. Very good. So now let's talk about the value E. Let's talk about the value of E. So we've introduced exponential functions. We've talked about functions of the form a to the x, which is an exponential function with base a. Now let's talk about another. Let's talk about information that will lead to the natural exponential function. So the value of E, notice that you'll see E on your calculators and you'll see how to apply it and things. E is a real number. It's not a variable. To 9 decimal places, E, wavy equals means approximately. E is approximately 2.718281828. The natural exponential function, you'll often hear us just say the exponential function. The natural exponential function, f of x equals e to the x with base e, okay? It is the exponential function, f of x equals e to the x with base e. It's often referred to as the exponential function. Properties of the graph of y equals e to the x. So first of all, let me shift this up a little bit. So properties of the graph of y equals e to the x, the domain is all real numbers. The range is 0 to infinity. What does the graph look like? It looks like this. Has similar shape as a to the x, where a is what? Has a similar shape to the exponential functions we talk about, a to the x, where a is what? It gave two cases. Greater than 1. Good. It has the same shape as that. So notice that here, this would be 0, 1. That would be your y-intercept. Why? Because y equals e to the 0. E to the 0 is just 1. 3 points. You also know when you get 1, you have y equals e to the 1. E to the 1 is just e. So you get the point 1e. And then what do you get for y when x is negative 1? 1 over e. Good. You get 1 over e. And 1 over e is approximately, so 1 over e is approximately 0.37, just so you know. You won't really use it a lot, but just so you'll know it. So notice that the domain is all real numbers. The range, 0 to infinity. The y-intercept is 0, 1, and the x-axis is your horizontal asymptote. So get close to 0, but never equal to it. Okay? So, let's go through an example. We're going to graph each of the following functions, and like we did on the previous page, in example 4, what we're going to do is specify the domain, the range, the intercept, and the asymptote. Okay? Would you like a minute to try it? All right, let's go for it. So you have, in part 1, you have y equals e raised to the x minus 1. We need to specify the domain, the range, the y-intercept, and the asymptote. Okay, let's first graph it. So it takes the graph of e to the x, which is here, and this minus 1 means shift e to the x right 1. So we take that and we shift it right 1, and when we shift it right 1, what does this point become? What's the y-intercept? 0, 1 over e. 0, 1 over e. Good. So this, your y-intercept is 0, 1 over e. Remember, you can do that by also substituting x equals 0. So you would have y equals e to the 0 minus 1, which is e to the negative 1, or 1 over e. Okay? Now, you have that. What's your domain? Interval notation. Negative infinity to infinity. What's your range? 0 to infinity. Good. And what's your asymptote? The x-axis. Good. Remember that participation is a part of your grade. So just an FYI to respond. You have y equals negative e to the x minus 1. What's the graph?
We're not finding the x-intercept?
No, we don't need to. Is there an x-intercept?
No.
There is no x-intercept. There is no x-intercept. Okay, so again, what's the graph of y equals negative e to the x minus 1?
It's part A, but reflected about the x-axis.
Part A reflected about the x-axis. Good. So it looks like this. Okay, so that's negative e to the x minus 1. What's the domain? Negative infinity to infinity. Good. What's the range? not 0 to negative infinity.
Negative infinity to 0.
Negative infinity to 0. Good. What's your y-intercept?
0 and negative.
Good. 0, negative 1 over e. What's your asymptote? Good. Now, what is the graph of y equals negative e to the x minus 1 plus 1?
Would it be right by 1 and up by 1?
Say again.
Would it be right by 1?
What's moving right by 1?
E to the x.
E to the x would move right by 1,
Right by
that's
1.
this minus 1.
Yep, and it would go up by 1, just the plus 1 on the outside.
But you're forgetting something.
And then it's also flipped over the x-axis.
So you can really just take this graph and do what with it?
Just move it up by 1.
Move it up by 1. So take this and shift it up by 1. So taking this and shifting it up by 1, we get what as our, what do we get as our y-intercept?
0, 1 over e.
No. Remember, you're taking this, taking the green, and you're shifting it up by 1. So you'll have something like that, exaggerated. So this would be negative e to the x minus 1 plus 1. Remember, to find your y-intercept, you set what equal to 0? Good, you set x equal to 0. So this is your y-intercept would then be negative e to the 0 minus 1 plus 1. This would give you negative e to the negative 1 plus 1, negative 1 over e plus 1. 1 over e is approximately 0.37, so that's negative 0.37 plus 1. So it'll be 0.63. So, or you can just say this. What was your question? Okay, those happen, it's fine. So your y-intercept would be 0, comma, negative 1 over e plus 1. What is your asymptote?
X equals 1.
X equals 1, very good. Oh, no, x equals 1 is vertical.
Y,
You're right.
equals 1, yeah, right.
Good. Y equals 1. Y equals 1, because notice that your negative 1 over e plus 1, that's going to get closer and closer to 1, but never equal to 1. As x goes to negative infinity, that's going to get closer and closer to 1, but never equal it. Okay? What's your range?
Negative infinity to 1,
Negative infinity to 1.
right?
Yeah.
Yeah. Negative infinity to 1. Good. What is your domain?
Negative to, repeat the same stuff.
Same as the possible x values?
Yeah. I don't know, I'm confused.
It's the blue, but you're reading the x values. What x values are possible?
All real numbers?
All real numbers. So how do you write that in interval notation? Anyone.
Negative infinity to positive infinity.
Good. Negative infinity to positive infinity. And there you go. Good. So make sure you work through the homework, because the homework is gonna give you more practice with shifting exponential functions, and that's what you'll need practice with. Okay, shifting them and actually evaluating them at specific numbers. Okay? Now, an application of exponential functions, an application of exponential functions is compound interest and continuous compounding. Okay? So, let's start with the definition. Compound interest. Compound interest is calculated by the formula A of t equals P times the quantity 1 plus R divided by N raised to the N times T, where A of t is the amount after t years, P is the principal, R is equal to the interest rate per year, N is equal to the number of times interest is compounded per year, and T is equal to the number of years. Okay? So this is the formula for compound interest. You'll need to know that. Okay? So let's look at an example. If $4,000 is borrowed at a rate of 5.75% interest per year, compounded quarterly. What does quarterly mean?
Every
4 times a year.
Four times a year. 4 times a year. Okay? So, find the amount due at the end of the given number of years. So, 4,000 represents what? Say it again, I heard two things.
Principal.
It's your principal. Good. 4,000 is P. So we'll have A is equal to 4,000 because that's P. Then you'll have 1 plus, what's your rate?
5.75%.
So what do you need to do? Divide it by 100. So, or move it over 2 decimal places as you said. And you get what? Move it to the left. Go ahead.
0.575.
0 point what?
0.0575.
0.0575. Good. So that's your rate. Divided by
4.
4. Good. Raised to the
4 times 4, so 16.
oh, you're doing part A. That's part A. In general, it's just T.
Oh, okay.
But then, no, you're good. But for part A, yes, go ahead and do that. For part A, T is 4. And so you'll be able to go ahead and find that. So good. So in general, A is equal to this. But now we want to find A in part A when T is 4, B when T is 6, and C when T is 8. So we'll have A of 4 is equal to 4,000 times the quantity 1 plus 0.0575 divided by 4 raised to the 16. And what do you get? That's approximately. Remember, you're talking about money, so out to 2 decimal places. What do you get? Okay, what did you get for part A?
5,026 and 16 cents.
Very good. So you get 5,026.16. So your answer would be the amount due at the end of 4 years is $5,026.16. At the end of 6 years, you have A of 6 is 4,000 times the quantity 1 plus 0.0575 divided by 4 raised to the what power? 24. Good. And what is that approximately?
$5,634.10.
Good. Very good. 8 years. A of 8. You get 4,000 times the quantity 1 plus 0.0575 divided by 4 raised to the what power? 32nd, good, and that's approximately what?
$6,315.58.
You got it. So that would be the amount due after 8 years. Okay? Now, if this is the formula that you use whenever you're compounding quarterly, semi-annually, annually, a certain number of times per year. Now, if you're always compounding interest, if you're continuously compounding, you use a different formula. Okay? That's on the next page. So, definition, the continuous, or not the, we could just say continuous compounding. Continuous compounding is calculated by the formula A of t equals P times e to the RT, where A of t is the amount after t years, P is your principal, R is your interest rate per year, and T is the number of years. And T is the number of years. So this is continuous compounding. So if $8,000 is invested in an account for which interest is compounded continuously, find the amount of the investment at the end of 12 years for the following interest rates. What is the formula in general for this problem before you start substituting in the rates? What would it be given by? A equals what? What's P? Yes, but for this specific
8,000.
problem, yes, 8,000. Where does that go? In the exponent, 12 times R. Good. So that's what you use in general. Very good, both of you. So you have A is equal to 8,000, E raised to the 12R, and then you have your different rates given in A, B, and C. Would you like a minute to try those?
Yes.
Okay, go for it. Oh, and D is 7%. So whenever you have 2%, that means R converts to what? 0.02. So good, you have 0.02. So you get A of 12 would be equal to 8,000. E raised to the 0.02 times 12. That was approximately what for you? What'd you get? Okay, you say you're ready. What did you get?
10,169.99.
Very good. 10,169.99. So what's the conversion for 3%? 0.03. Good. So A of 12 would be equal to 8,000. E raised to the 0.03 times 12. That's approximately what?
1,466.63
And what?
63 cents.
Did everybody get 63? 64.
That's 1 cent.
Yeah, but it counts. It needs to be accurate. Okay. 4.5%. What's your conversion?
0.045.
0.045. Good. So you get A of 12 is equal to 8,000. E raised to the 0.045 times 12. And what did you get approximately?
13,000.
Can't hear you. Say it again.
13,728
And 5 cents. Good. And then for 7%, what did you get for your final answer? The conversion was 0.07. What did you get for your final answer?
18,530.94.
Very good. Okay, so these are your applications of exponential functions, okay? And that concludes sections 4.1 and 4.2. If you have questions, let me know. Don't hesitate to reach out to me. Have a good one and see you on Wednesday. Remember, you have your test on Wednesday.